actually true.
Here's my screen. Okay, so we're going to actually start chapter 7 today. But we're going to do this first. So I'm making you go backwards. We're going to start going backwards more and more. So this is what you want to make. I want you to figure out what you would use for your nucleophile. Did I open it? Yeah, okay. I got 19. I could have done it like.
Why didn't you just use straw?
Because I expect the number to change. That's usually what happens. And the act of writing it down helps me remember, not writing it down. Have you not noticed that? Yeah. It may be different for you. Depends on how you learn. All right, so I got 2 more. Okay, let's go. I got every answer. Okay, so first of all, let's kind of go over a little bit. We want to know what you would use plus ethyl bromide. Did anybody write down ethyl bromide and look at it?
Yeah.
Okay, good, because that would be a good way to approach it. Okay, where are those 2 carbons, do you think, in that molecule? Like, where do you think they ended up?
On the left one?
Mm-hmm. These 2. That makes sense? Why can't they be these 2? Because that carbon has a carbonyl on it. Okay. All right. So what's going to be your nucleophile? It's going to be this piece. And what's your leaving group? Okay. So which one is it? Does that make sense? Okay. Notice down here. This was the other popular choice, was it not? Yeah. Okay, 1, 2, 3, 4. That's all your carbon. There's only 4 carbons in the whole molecule. So 4 plus 2 would give you, if you took this plus ethyl bromide, what would you get? I'm just going to do that. Okay. So this would go here and that would leave. So what would you get? You would end up with 6 carbons in it. Okay, so that makes sense. It's very logical. I know it's amazing when it is like that. So. All right. Alkenes are typically hydrocarbons. They contain a carbon-carbon double bond. An old term for them is olefin. Okay. Olefins. Okay, because when ethylene reacted with chlorine, you got an oily substance, and that's kind of how that term came about. Doesn't get used that much anymore, but you will see it in textbooks, and if you had to look something up, you'd probably run into that word. It's not a word that I use very much. I'll say alkene. Okay, and this alkenes are considered unsaturated. That means that they don't have all the hydrogens that those carbons could hold. We don't have them all. Okay, so this is ethylene, which is the simplest one. There isn't a methyl, right? You have to have so ethylene, does anybody know what this is? A banana tree. Okay, I've seen banana trees in Jamaica. And ethylene is produced by bananas. And ethylene is what makes fruit ripen. Okay, so does anybody know anything about tomatoes? When
They're
they
delicious.
like them. Okay, not everybody likes tomatoes.
I love tomatoes. Jackie Wire.
Don't tell Jackie I said that. Okay, I might get in trouble. But she always gets her food with no tomatoes.
We don't even eat avocados.
What? Okay, so when they pick tomatoes and ship them, they're not red, are they? They are green. And then when they get to the store, they spray them with ethylene and they quickly ripen them. Okay, and then they put them out for y'all to buy. Okay, so why don't they taste as good? Have you ever heard that? You grow your own tomatoes, they taste better than the ones you buy at the store, because the ones that were ripened at the store were ripened really quickly. If the tomato is allowed to ripen slowly on the vine, it will develop more sugars and flavors and stuff in it. Okay, and that's how it comes. If you have a fruit that doesn't want to ripen, have you ever done any tricks to try to get it to ripen faster?
You can stick it in a bag.
Stick it in a bag. What does that do? Well, if you stick it in a paper sack, what will happen is the fruit will continue to ripen over time, but it will form ethylene. And the ethylene will stay in the bag, and that will help its own ethylene to ripen faster. Bananas are super ethylene producers. So what happens if you buy a banana and you leave it on the counter for a week?
So
Right.
why in your fridges, why do they say to put that stuff at the bottom that it keeps it like your fruits and your vegetables? Like you have like drawers in your
Keep them in the
fridge.
crisper.
Yeah, I thought that had to do with humidity level.
Oh, I didn't know if it like helped filter out
Ethylene?
the or something.
I don't know. I've only heard about humidity levels.
Yeah, because there's like the humidity control slider.
Yeah, that you can, yeah.
I feel like that's just a hoax. That there's really
Oh.
that's just-
Well, if you put a banana in your bag with your fruit that's not ripe, like a peach or something, you should try that sometime. It'll ripen super fast. Okay, because bananas are super ethylene producers. Okay, that's why they turn black and yeah. Yeah, avocados are the most frustrating.
well, Walmart sucks. That's why it's so frustrating.
Ah, well, that explains it. Okay, alkenes naturally occur, and here are some examples. The top one is isobutylene. It's used in the production of synthetic rubber. Okay. The one down here is alpha-farnesene. It's present in the waxy coating on apple skins. You know, that's farnesene that you're looking at. Okay, and this is alpha-pinene, which is in turpentine. Gives it that unique odor. Okay. There's like lots of them. Okay, and we'll see some over the course of the chapter probably. Okay, so the simplest one is alkene, or ethylene. The simplest alkene is ethylene, and the ripening agent, and ethylene is its common name. Its IUPAC name is ethene. So if you had this, that's called ethene. Okay? What we're going to do is we're going to change it from ANE to ENE because it is an alkene. You only have to have one double bond. Okay, you can have more, but you only have to have one to be an alkene. Okay, so this propylene is the common name for that, but its IUPAC name is going to be propene. See how we get that? That means that you have 3 carbons in the longest chain and a double bond between 2 of the carbons. Okay, doesn't matter in these where the double bond is. For example, if I wrote propylene like this, is it different? No, it's not different. It's just flipped. Okay. Okay, so what's going to happen is we're going to how many carbons next? 4. Now we're going to have choices, okay? So when you're going to name more complicated alkenes, you're going to find the longest chain that contains both carbons of the double bond. That is important, the both. Okay? You're going to actually number the chain so that the first carbon in the double bond gets the lowest possible number. Okay? First carbon gets the lowest possible number. The ending is ENE instead of ANE. You're going to give the number of the double bond position, that first carbon of the carbon-carbon double bond, you're going to have to say that number. Okay? You put the number in front of the base name with a hyphen or in the base name before the part of the name "ene," and I will show you that. Okay? You can do it either way, this way or this way. We don't do both. You pick one. Okay? This is a little bit older. This is a little bit newer. You'll end up seeing both in the homework, both in the book. When you do the nomenclature and you put in your name, I've tried to check all the questions, and it doesn't matter which way you put them in. Just pick one way and stick with it is what my advice is. Okay. All right, so here is this top one. There are 5 carbons in that chain. So the base is going to start with pent, right? And then it's going to end with ENE. Okay? You can number that chain from left to right or right to left. You start at the end just like we did before. Okay? So if you started over here on the right, the first carbon of the double bond would be 4. Okay, so which is lower, 1 or 4? 1 is lower, so it's going to be 1 pentene. See how we get that? Goes all the way in the front. Now, if you put it the other way, it'll look like this. You'll put pent -1 -ene. And you do have to do that correctly in the homework. If you do the first one, you only put the hyphen after the number. Now, what if there was a methyl on there someplace? Like 4, methyl on carbon 4. It would be 4-methyl -1 pentene. Do you want me to write that?
Yeah.
Okay. So I feel like there's not enough room, so I'm going to do it on the board. Oh, hey, wait, maybe I can do this and get more room.
Oh wait, you can just do the third example.
Yeah, the third example.
This one, yeah. Okay, so this one is, we have a bromine. Wow. Okay. I try to lock those things so that that doesn't happen, and we have a methyl. But notice that the bromine's on 1, but we're going to number our chain from the left. 1 for the double bond wins. So that kind of simplifies a whole lot of nomenclature because we now have a real functional group in here. Okay, so the base for this one is going to be 1, what? How many is 4, y'all? Okay, and then in front of that, we're going to put our methyl on carbon 3 and our what? How do you do bromine? Bromo on carbon 4, and you put them in what order? Alphabetical. Is it all coming back to you now? Okay. So it will either be 4-bromo -3-methyl -1 butene. You don't say the hyphens. You would say it as 4-bromo 3-methyl 1-butene, but I want to make sure you put them in. Okay, or you could do 4-bromo 3-methyl but 1-ene.
So on the homework,
You can do either one.
To know which one it wants.
It doesn't matter. That's why I said I did it all the ways. So it will take it no matter which way you want to use. And when you do your test, I mean, if it's a multiple choice, I'm not going to give you both of them to pick from unless I want you to do A and B or something stupid. Okay? But would I do that? But at the end where I give you the compounds and you have to write the names, I don't care which one. I'm good at both, so I'm fine grading both. Okay, is that good to know? Okay, but do you see how we stick with the alphabetical, all like before, okay? The other rules don't go away. Okay, so what's the name of this one? The second one. 2-hexene. Or hex-2-E. Whichever one you want to do. Okay, now, do you remember I told you that the carbons of the double bond have to be in the longest chain? So notice down here on this bottom one, if you go 1, 2, 3, 4, 5, 6, or you go 1, 2, 3, 4, 5, 6, I get 6. If I go across, what do I get? I get 7, but the double bond is not in your base chain. So it's going to be 6. So do you go to the left or the right? Why did we go to the left? Because the chlorine gives you you have 2 substituents. Okay, if you went to the right, you would only have 1 substituent. That would be complicated and you would have to use those parentheses that I know you love dearly. Okay, so remember the longest chain must include the carbon-carbon double bond. Okay, so what is the name for that, you think? 6 chloro.
3 propyl.
3 propyl.
1 hexane.
1 hexane. You getting it? I mean, it's been a little while since we did nomenclature stuff. Feels like forever ago. Okay. Any questions so far?
Go back.
Go back, why? Now look what happened. What are you writing?
The name.
What?
The name.
Oh, well, okay. Quite fast.
Well, I'm not writing. She's writing.
Oh, did you get it?
Yeah.
She's good.
I'll show
All
you.
right. All right, so how would you name this one? Okay, you might have to write it down on your paper and look at it. We still only have 19 clickers.
I like your sweater, by the way.
Oh, thank you. A friend bought it for me. I think she got men's size. It's like huge. I told my husband, you can wear this. I also have a shirt with it on that another friend got me. This was quite popular a few years back. And it's long sleeve green shirt, so I'll wear that after the break. Put up there. That's what you think is the best one. I had a student in my physical science class. He said, I just had to pick that answer one time. He picked it one time. Funny.
I feel like I'm missing something.
You feel like you're missing something. Well, we'll go over it and maybe that'll clear it up if you were forgetting something.
Okay.
I don't know.
Like I've heard it.
All right, y'all pick one. Okay, here we go.
Wait.
Whoa, whoa, whoa.
Okay, never mind. You changed mine.
Hey, it's green like
Okay. What's the longest chain?
that.
7. 1, 2, 3, 4, 5. Why? Yes. So what have we got? Methyl and ethyl. 5 ethyl, 6 methyl, 1 heptene. Everybody see where the 1 heptene's coming from? And see, I didn't give you that, or 5 ethyl, 6 methyl, hept, 1 E. Yeah, I mean, that's just not gonna help. You want me to do that?
No.
Oh. Okay, we're going to add in ethers in this chapter because they're really easy. And they come up in this chapter, okay? Ethers are usually named as substituents on whatever the base chain is. You take the name of the alkyl group, drop the YL, and add oxy. Okay, so down here you can see this is ethoxy. Did we get it? Oxy for oxygen. Okay. This is an isopropyl group. They don't go away, y'all. So this is isopropoxy. See how we got that? This was a T-butyl group, so this is tert-butoxy. Okay, are you getting how we get it? They have no special priorities. They're alphabetized like regular. So if you had diethoxy, it'd be alphabetized by the diethoxy. You'd alphabetize it by the, what was the rule? The E. Remember, di, tri, those things don't count. I told you I wasn't there when they made the rules. I think that's silly. It counts in the dictionary.
It doesn't.
All right, so what is the IUPAC name for that now? Now that you know all about ethers. Oh. Really should be putting Harry Potter names because that's the movie that's coming out. Mm-hmm. Neil Armstrong. Isn't something coming out on Thanksgiving? We usually have movies come out on Thanksgiving.
I think the Wreck-It Ralph movie.
Oh, that's cute. I don't have little ones, so. I'll go over it, so. All right. Get up on my bad foot. Are you confused? I only have 18. Okay. Oh, I hope it's B. Okay, so which way do you want to number the chain? Left to right or right to left? Why? The double bond gets the lowest number. So we're going to go 1, 2, 3, 4, 5. Our groups are, what's that? Ethoxy and a methyl. Okay, so you're going to put them in alphabetical order. So it's going to be 4 ethoxy, 2 methyl, 2 pentene. We got it? Any questions? Any concerns?
So does the
So does the what?
oxygen makes that the
Ethoxy? Yes.
the
The oxygen makes it the ethoxy. When you pick your base chain, sometimes it helps to like circle it or highlight it. Okay, so you know those carbons are taken care of. Okay, what do we have left? We have this left and this left, okay, to put into our name. Does that make sense? Okay. Okay, what if you have more than one double bond? Because we can do that. Okay. Give the double bonds the lowest possible numbers. Okay. Put the first numbers for the carbons of the double bonds before the base name. And you're going to use diene, triene, etc. in the base name. Okay. So look at this molecule on the left. You have to have both carbons of both double bonds in your chain. Okay. So what's the longest chain? How many? I count 5. It goes to 5. Okay. So that gives you pent. Okay. Now what's the ending going to be? Diene. So we don't write pent-diene. Okay? You actually put A-D-I-E-N-E. Pentadiene. Because I think it's just an English thing because of saying it. Okay? What goes in front of the pentadiene? Okay. So does it matter which way? No. This is going to be 1, 4 hyphen. Okay, so what about this one over here on the right? How many carbons? 7. Did everybody see there's 7 here? Okay, which way do you want to number this one? Left to right or right to left? Okay, why? Because you have a methoxy on carbon number 3 that way, and the double bonds are the same. Okay, remember when we did other things and it was like if it's the same, that like the rings, you want to get the lowest numbering. Well, in these you're going to want the lowest numbering with the double bonds first. If it's the same, you worry about those substituents. It's kind of weird. Okay, so what is that going to be? 3 what? Ethoxy, 1,6-heptadiene. Okay, so here they are, the way that the normal, the old way. And notice they put that A in there again. Okay, this is how you do it if you do it the newer way. And I haven't seen any preference for the new way, by the way. Okay, notice they go penta hyphen 1, 4 hyphen diene. And that other one is 3-methoxy hepta hyphen 1, 6 hyphen diene. Okay, so it's just whether you want to put your numbers in the middle of your base name or at the front. Just don't do both. Okay, just don't do both. Yeah? Okay. I'm trying to walk you down the little path. Okay, you can have groups on molecules that have double bonds in them. There are 3 names that you need to learn. This one, do you remember that we talked about this kind of an alkyl halide? And we said that alkyl halide was, what was the name for it? It was a vinylic type. Okay, so this group is, boy, just boil my thunder. This group is a vinyl group. I'm telling you, I plan these things out. Okay, so if you had this, what kind of alkyl halide is that one? It's on the carbon next to the double bond. This is on the carbon of the double bond. If you're next to the double bond, you are allylic. That's an allyl group. So you kind of see where they get the names a little bit. Okay, this is a weird one. Do you remember what this group is called? Let's see if that helps. What is that group called? An iso who? Propyl. Okay, do you see how that's similar to that? Okay, it's an isopropenyl. Okay, so remember that the carbons of the double bond are vinylic carbons. The carbons next to the double bonds are allylic carbons. Okay, that might help you with some of those names. Isopropenyl is the only one that has the EN in it.
So if this is like in a compound and you already have like 2 other double bonds,
You would name that as the group. Like that would be a vinyl group.
so the name of like the compound that it's like on it, it's not like a triene if there's already 2. It's like,
Well, you can have 3 in your base chain.
but if there's
But if there's 2 in the base chain and 1 hanging off, then that's going to be a vinyl group. Okay. So it'd be like 3 vinyl, 1, 6 decadiene. Okay. Okay. All right. What if they're in the rings? So what do you think the name is of that compound that's up there, right there? Okay, what if it doesn't have the double bond in it? What is it called?
cyclohexane,
So what do you think it is?
cyclohexene.
Yep, it's that simple. Why, Caitlin?
I just don't. It's so weird.
Well, if you
It's so weird.
Yeah.
if you name it, it doesn't matter.
Class of the band, like,
Yeah.
I'm sorry.
I mean, I get it, but I was just like,
All right, now there's like, okay, so now look at the one below. Okay, you see that one below? What's different about this molecule from this one?
there's a
We have a methyl group in there, okay? Did you notice that we didn't say 1 cyclohexene? Anybody pick up on that? Where's the 1? The carbons in the double bond must be carbons number 1 and 2.
So it's just like redundant to put 1.
Yes, it's kind of like redundant to put 1. Okay, there is no way to have 2 cyclohexene. Now, if you had just hexene, you could have 1, 2. See, you can move that double bond around and they're different. But in a ring, they're all the same. It's just how you rotate it. So, in the double bond compound, that's the ring, this is going to be carbon 1 and this is going to be carbon 2. 3, 4. Why don't I go the other way? Because you want this to still get the lowest possible number, but you're limited. Now you're being told the double bond carbons have to be 1 and 2. They have to be 1 and 2. Okay, so the name for this one is 4-methyl cyclohexene. And notice there's no 1 in there. Okay, what do I have over here? No, number 1. I'm like, what did I put over there? All right, now look at the one on the bottom. Okay, what's your base name for that? Cyclopentene, okay? If it has a ring, you write cyclo. If it doesn't have a ring, don't write cyclo. If I give you a molecule to use in a question and it doesn't have cyclo in it, the name, don't put cyclo. Most common problem. And then go, you know, it doesn't make sense. I don't know. That's because you put the cyclo in there. Like, double check. All right, so we got what for our base? I'm going to write that up here. Cyclopentene. All right. How do you want to number that? Yeah, the double, but which way?
That way.
Top down or bottom up? If you go top down, this first substituent is on carbon number. If you go bottom up, the first substituent is on carbon number.
Well, if you go the other way, it's 1, 2, 3, not 1, 5.
I know, but the first, you want the, just like when you're numbering your chains, you want the first substituent you come to be number, the lowest number. It's the same thing in these. Because remember, if we had something like this, which way would we number? From the left, even though that's 3, 3. Okay? You have to number this way. Summer rules. Keep telling you, don't blame me. Okay, so it's 5-ethyl 1-methyl cyclopentene. Okay, not 3-ethyl 2-methyl cyclopentene because 1 is less than 2. At least it always has been. As far as I'm aware. Even as a small child. Okay? Don't worry, we'll get to practice that some more. All right, so how are you going to name the top one?
Well, I don't know. Wow. One
Okay.
on the right, coming off the double bottom.
Okay.
That one's yeah.
So what one has to be 2 now? Do you notice you can't go 1, 2, 3? Okay, it's got to be 1 and 2. All right. So what is it going to be, the name? 1,5-diethyl cyclo who? Okay. Bless you. All right, what do you think about the next one?
One's got to be on the bottom.
No.
One's got to be on the bottom?
Well, I meant like right there. But no, because it has to be 1, 2. What? This is so. I'm so
That and she was down there. And then you just go all around.
I'm very concerned and bothered.
Yeah.
So it's going to be what? 1,5-dibromo cyclopentene. Okay. Not that one. All right. What do you think about that one?
4-vinyl cycloalkanes.
You don't even know? What's the base name?
Cycloalkanes.
1, 2, 3, 4, 5, 6, 7, 8. Okay. Who do you want to be carbon 1?
I would say the one over in the top left, but there's 2 reasons, so I'm not confident.
So it's cycloalkene. What is this? It's a vinyl group. Here's your vinyl, Alexis, right here. Got it? Okay, so what is the name of it?
4-vinyl cycloalkanes.
Come on. Notice it's cyclo-O. The spelling, it looks like cycloalkene, but it's not, it's cycloalkene. Okay, does that clear a lot of stuff up? It just takes a little practice. You will get where you liked having other functional groups in there because it simplifies the naming, really.
As long as it's naming.
Yeah, this is better than the other stuff, but it's still kind of
All right. What if you have multiple bonds in the ring?
well, I feel
Okay. You cry?
normal has to be.
Oh. Okay. So notice that you could have that compound like this, the double bonds like that, or the double bonds like this, and they're different.
Well, yeah, because they're two different ones.
Yeah, see how they're different? Okay, so because of that, now you have to use numbers. Okay?
Always using numbers?
No, not for the rings. We weren't putting in the one, remember? Okay. So now you will have to put numbers in, okay? And you want to give the double bond system the lowest possible numbering. Okay, so do you see that you're going to start numbering here or here? Like you wouldn't start numbering here
Why?
because your double bonds would be 1, 5.
Okay,
So when you have two double bonds, it trumps the other things. Okay, nothing about our president. Okay, it's cards. It's cards. Okay. So we're going to number it like this.
You're just trying to give them all the lowest number.
What?
You're just trying to give them the lowest number.
Yeah, you're just trying to give the double bonds the lowest number.
if you have two.
If you have two.
And two trumps everything we just learned.
Yes.
Okay, just to be clear.
Okay, so this is going to be, we'll do that top one too. Ooh, ooh. Okay. You can put the numbers in the base name like we did before, which would give you, it would, or,
Remember, it's diatribe.
First.
What is this? Oh, that's her. That's the funky one. I don't know what it is.
yeah, most of the students don't like that, but I've had students that really like that, just made it easier for them.
That's just
So, but you can do it either way. Okay, so how do you think we're going to do that top one? What carbon do you want to be one?
I feel like it matters.
It kind of matters. Like, do you want this one to be one?
No.
It's got to be this one or this one, right?
Correct.
Okay, so if I start over here, I'm going to go 1, 2, 3, 4, 5.
But yeah.
Yeah.
I'll put you.
Okay, so it's going to be 3 bromo, 1, 4 cyclohexadiene. What? Okay, how about the bottom one? What do you think about that one? How do you want to, I guess I should write in the numbers. How do you want to number? Start on the left here? Here.
Yeah.
And go 1, 2, 3, 4, 5, 6. And I'll go all the way around so you know how big the ring is.
3,6-butyl, 1,5-cycloalkane.
It's not a sex butyl group.
Oh, it's not 6-butyl.
No.
Oh, I don't know.
That was wrong. What is happening in the world?
Sorry, nomenclature was a while back.
No, if you're wrong, there's no hope.
That's isobutyl.
Yeah.
That's all right. You'll have time to review over the holidays.
Octa, we forgot that.
3-isobutyl 1,5-cyclooctadiene. So you see that you can get 1,5 for the double bonds going different ways, but you're still wanting to give your group the lowest number you can, while keeping the double bonds at the lowest possible numbers. Okay? Okay, that's why on the back of the pre-med club shirts it says help, I'm a dying.
Oh, that's a
Are we
clicker.
not-
We don't need
Want
it.
a clicker?
We don't need it.
Oh.
Clicker? Let's not do it. That's all right.
Yeah, let's do it because it's easy. You got it now. It's easy. Let's do it. Dark matter?
Hey, look, he start popping stuff again.
Start popping stuff.
He'll pop his whole body and just sit there, and it
I'm jealous.
breaks us all out.
You're jealous?
It
You
sounds
want
like
to pop your
When I
body?
go to the chiropractor, I don't do it myself.
if you like really like this pop necklace, like when you hear somebody else do it, it like makes you like want to do it and like. I don't
Yeah,
know.
but
I just like yeah.
I don't care if you pop your knuckles. When you pop his whole body, it scares me.
If I see somebody pop their neck, I have to.
I feel like that's a disorder.
I don't know. Probably. There's probably lots of them.
All right, I got 16. Do I got 3 more?
I don't get this right with your cry.
Yeah, I'm gonna be very sad.
Do I need 19? Did somebody leave? Make a choice. If nothing else, put E.
You can't change it, Cass.
You can change your answer.
Yeah.
Oh. All right, I'm clicking it. Does everybody know that it took it?
Okay.
I'm in the
Okay.
hospital.
So how do you number that ring? Which carbon is 1? The top one or the bottom one? Okay, that has to be 2. Now we're going around. See, I told you it was easy. You got it. Okay. Okay, the only thing I'm going to tell you about this right now is the bond angles. Remember that when you are a carbon that's double bonded, what is your hybridization?
SB2.
Yeah. Okay, what's your geometry? Yes. And notice that that the angles aren't exactly 120, but they're close to 120. Okay? They're close to 120. Okay? I don't want you to learn all those angles. And I want you to notice that the bond lengths in here, this bond length is shorter than a CC of ethane. It's shorter. As you go up in hybridization, the bond lengths are going to get closer and closer together. Okay, that's going to make a difference for reactivity. Okay? All right, I will, y'all have good turkey day, and I will see you on September 7th. I don't even know. When in a week or so.
Let's go back a lot.
You don't like turkey?
Oh,
It's
ham
always
all the
dry.
way.
It's always
Oh,
dry.
ham.
Oh, I'm cooking a ham in a couple hours.
No, listen.
I cook it in the bag. That's the key.
Somebody in our family deep fried one last Thanksgiving, and oh my god, it was so
That
good.
is-
I have heard that.
It's so good. If you, as long as you like don't blow it up or whatever, you know.
Yeah.
It's so good.
I'm so lucky I get leftovers.
Oh, this, oh, I hope so too. I do not. I do that like every.
Okay, can I